Hey there, Algebra 1 kids. It's Miss Barrett here, and I'm about to do some problems for you. I actually picked out like 8, so hopefully I don't take too long for each one, so the video is not too long. But I just felt like we didn't have enough time to go through everything I wanted to, so I'm going to give it a go on this video. Starting with number 74, this is in the solving equations unit. This is called solving literal equations, where you have to get one letter by itself. I think I briefly went over this in class, but I want to make sure that you guys understand it. So here I am solving for r. So what does that mean? It means that I want to get r by itself. So in order to do that, guys, I could still use the chart. There's lots of ways to do it. I'm still going to use the chart. So if I'm getting r by itself, that's what I have to put at the top of the chart. And then I have to think about what's happening to r and in what order. So the first thing that's happening to r is that we're multiplying by p. We're also multiplying by t. Since that's both multiplication, you could do the t first and then the p. It really actually does not matter, as long as you understand that we're multiplying p, r, and t all together. And that equals I. So going on the other side of things, we're going to start with I, and we're going to divide by t, and then we're going to take that and we're also going to divide by p. So this looks a little interesting on the when we actually write it out. So what I like to do is start with r equals, because that's what I'm trying to get. Start with I on top. If you're dividing, okay, it goes on the bottom of the fraction. So I'm dividing by p and by t. So I could write divided by t, and I'm dividing by p, so they both go on the bottom since I'm dividing by both. Another way to write this is r equals I over pt. It does not matter which order. It could either be t, p, or pt. It's the same thing. In a multiple choice test, you're not going to see both of those answers. It'll be one or the other. So that's number 74. Let's go on. Moving on to number 81, which is an inequality problem. So inequality is when we have the greater than, less than, greater than or equal to, and so on. We did a lot of stuff with this. We did it very fast in Unit 4, I believe. So for this one, I'm going to rewrite the inequality down here. 16 minus 3x is less than or equal to 19. Guys, the goal here is to get x by itself. So to start this, I want to get x totally alone. I'm going to subtract 16 to both sides. We pretend like that inequality right here is an equal sign, and we solve the same way we would if it was a regular equation. I'm going to drop down the minus 3x. I'm going to drop down the less than or equal to. 19 minus 16 is positive 3. All right, next step is going to be to divide both sides by negative 3. Why? Because I want to get this x totally by itself. But something really interesting happens here. I know we talked about it before, guys. First of all, I'm dividing by a negative number. The number on the bottom of this fraction is negative, so that means I need to flip my inequality sign. I'm left with just an x on the left side. Oops, I should have written negative 3 down here, guys. So 3 divided by negative 3 is negative 1. Okay, do not forget to flip the sign if you multiply or divide by a negative. You don't have to flip the sign if you're adding or subtracting. But this is my final answer. So my final answer on the line would be x is greater than or equal to negative 1. How would I plot that on my number line? Well, usually I like to put 0 somewhere on there. So if this is 0, then this would be negative 1. And to plot this, I'm going to do a filled in circle over the negative 1 because this inequality symbol is underlined. That means I have to do a filled in circle. If it was not underlined, if it was just greater than, I would have an open circle. And x is greater than, so I'm going to go towards the bigger numbers to the right. And that's number 81. Moving on to the next one, the third example. We have number 86. So 86 is also in the inequality unit. It's writing inequalities, and I just wanted to reiterate what a lot of kids seemed confused on what this type is when it's just like almost, it looks like a bar with 2 endpoints. This is an AND problem. It's an and problem because this is basically saying that the part that's shading is in between those two dots. So that means I'm shading some sort of overlap. Okay, I'm going to get rid of that so you can actually see what's going on. I like to draw in the arrows sometimes when I do a problem like this. So this just means that one arrow is going this way, the other arrow is going this way, and I'm shading in where they overlap, which is just right over this bar. Okay, so what does that mean? You got to look at the numbers. The numbers are -3 and 4. All right, so those are my magic numbers. And I'm going to write those down. I have -3. I also have 4 because the dots are over the -3 and the 4. Now, take a look at this top arrow. Starting at the -3, the bar is to the right, which means x is going greater than -3. And it's not underlined because it is an open circle. Okay, again, since the bar or the shaded part is to the right of the circle, x is greater than. Now, over here at the 4, notice that the bar or the shaded part is to the left of the circle. So this just means that x is going to be less than or equal to. It's underlined because of the filled in circle. And this is an and problem. So you could write and in the middle. The other way to write this would be a compound inequality like this. Oops. Where we have x is going to be between -3 and +4. Both are acceptable answers. But just know that when you have something like this with it almost looks like two endpoints with like a segment in between, it's an and problem. And now we're going to move on and talk about slope. So here we are talking about slope. You guys, this is or rate of change is what we really call it in this class. This is the rock formula. The formula looks like this: y2 minus y1 over x2 minus x1. So this is the rate of change. All right? Now, my points are given, and every point is x comma y. X comma y. I have my first point, so I put 1s with them. My second point gets 2s. And then I just plug into the formula. So here, I'm going to plug in y2 in this spot and y1 in the second spot. Don't forget that the y's go on top. It's always change in y over change in x whenever I'm doing rate of change. So I'm going to plug in y2 is 4 minus y1, which is -2, over x2, which is 3, minus x1, which is 1. Let's simplify. Guys, minus a negative turns to a plus. 4 plus 2 is 6. 3 minus 1 is 2, and I can reduce that, guys. 6 over 2 is 3 over 1, which is the same as just the number 3. And that would be my rate of change between these 2 points. Moving on to graphing. Here we have a graphing problem. This is point-slope form. Which is of this form: y minus y1 equals m times x minus x1. Guys, m always is your slope or your rate of change. Rate of change or slope is the same thing. So here, they give me my equation, and it's already in point-slope form. So all I have to do is figure out my rate of change and my point, and then I just have to plot and count. So here, guys, my slope is the number in front of the parentheses, which is 1 over 2, 1/2. Okay, so I'm going to use rise over run to count that out. Next, my point. My point comes from the numbers that are with the x and the y. Remember, guys, a point always goes x comma y. So it's just the numbers. It's the x1 comma y1. So the number with x is positive 1. Now, I have to do the opposite because in the formula, I have the opposite of x1. So, in other words, I have a positive 1 in the equation, so in my point, it's a negative 1. And I have a negative 2 for my y value, which in my point is going to become a positive 2. How do I graph that? Well, I just have to plot this point. Negative 1, positive 2 is this point right here. And then I count rise over run. Up 1, right 2, because it's positive over positive. So I go up 1, right 1, 2. I'm going to erase that so that you guys can really see. Okay, I started with my point. I went up 1, right 2. Draw my next point. Up 1, right 2. Another point. Up 1, right 2. And I can repeat this process until I have a bunch of dots. And I just graph my line. So again, my point was negative 1, comma 2. My slope was 1/2. Count up 1 over 2, up 1 over 2, and so on. Now let's talk about slope-intercept form. Slope-intercept form is y equals mx plus b. Again, m is my slope. This time, the b stands for my y-intercept. The y-intercept means it's on the y-axis. So whatever this number is on the end, you plot it on your y-axis, and then you count the slope. So, looking at my equation, I know that this number, this b number in the equation is 2. My slope in the equation is negative 2/3. Put the negative that's out in front, put it either with the top or the bottom, not both. I usually put it with the top. Again, my slope is going to mean rise over run. And this point 2 goes on my y-axis. All right, so plotting that 2, positive 2 on my y-axis, all I do is draw a dot, and then I count my slope. So this time I'm going to go down 2 because of the negative, and right 3, because it's over positive 3. So down 2, right 3. Down 2, right 1, 2, 3. Down 2, and right 1, 2, 3. So I get enough points to make a nice straight line, and there we have our graph. Slope was negative 2/3. Y-intercept, which we like to write as an ordered pair, is 0, 2. Slope-intercept form, guys. 2 more problems to go through. Here they give me the line, and they want me to write the equation. And they want it in slope-intercept form. So first we want to remember what slope-intercept form is. That's y equals mx plus b. Again, m is my slope. B is my y-intercept. So I'm looking for those 2 pieces of the puzzle, and then I'm going to plug it in to my final answer, which is going to be a number times x, and then either plus or minus another number. I like just to put that there for now, knowing that I need to look for my slope, I need to look for my y-intercept. So taking a look at my slope, you guys, from one point to the next, we're just going to count rise over run. Zooming in and counting, I go up 2, right 1, up 2, right 1, up 2, right 1 is my slope. I went a positive 2 over positive 1 because I went up and I went right, rise over run. So I could just write that as a 2. And that goes by my x because that's my slope. Now we're going to do the y-intercept. Guys, that's just looking. That's just looking right at the graph. Take a look. The y-intercept is happening where this line crosses my y-axis, which is up at 0, 6. So the number that's going to go into my equation is just 6. It's a positive 6. So my final answer for this equation is y equals 2x plus 6. That's slope-intercept form. Ta-da! One more problem to go through. Last but not least, this is another writing equation problem, but it's more of a word problem. This says write the equation of a line in slope-intercept form. Slope-intercept form is y equals mx plus b. That has a slope of -3, gives me the slope, and passes through the point -1, 3. Now, there's multiple ways to do this. I know teachers have different methods. Personally, since you guys know point-slope form, I like you to start there and then move things around. So we're going to start with point-slope form, which is y minus y1 equals m times x minus x1. Why am I starting with that? Well, it's easy. I'm starting with that because they give me a slope and they give me a point. If I know the point and the slope, it's very easy to plug into point-slope form. So all I'm going to do is plug in my y value and my x value. So y minus my y value of the point, which is 3, equals my slope, they give me that, -3, parentheses, x minus my x value. Now remember, it's minus a negative, which turns to a plus. So this is going to be +1 when it goes in my equation. That's point-slope form, so I'm not done. I still want to move it into slope-intercept form, but that's very easy, you guys. All I need to do is get y by itself. Once y is by itself, I'm in slope-intercept form. So I'm going to start by distributing that -3, so I can get the y totally alone by adding over the 3. So -3 times x is -3x. -3 times 1 is -3. Okay? And drop down the y minus 3 on the left side. Now, I just need to get x totally alone. I'm sorry, scratch that, guys. I need to get y totally alone. To do that, I'm just going to add this 3 over to the other side. Something interesting in this problem specifically is going to happen. Drop down the -3x, and then you would just add these numbers together. In this case, you actually get +0. So the final answer is y equals -3x. You don't have to write the +0 because anything +0 is just whatever that number was. But that's your final answer, and that's the gist of it. That's the process that you need to do. Okay, so I know I went over those fast. You guys can go back and rewind and rewatch and slow it down. I just wanted to make sure this wasn't a 45-minute video. I did go through 8 problems for you. Hopefully you watch this. Hopefully you're studying tonight and getting yourself ready for that final. Good luck, you guys. I'll see you tomorrow.